Dear colleagues, it's my pleasure to welcome here Tatiana Shavrina, who will give our next keynote on the relatively close topic to the first one. This is, I think, is one of the most interesting points of this day. So we see the rivalry. So Tatiana, please, the floor is yours.
All right, thank you. Thank you so much. So yeah, I think that my today's talk will, complements maybe the first opening talk of today. So we once again will be speaking about large language models and how they shape the landscape of research today. And I will be sometimes a little bit speculative because I come from computational linguistics, and I want just to give you some perspective on what's going on in terms of computational linguistics. But I also want to give you some kind of overview what's going on in the industry and what are the challenges, for computational linguists, for NLP practitioners, and also for corporate lawyers, because that's what we get right now. All right, so I've been doing large language modeling for some time now, and together with our amazing teams, we have been training such works as multilingual language models, the MGPT model, which is a large language model, which is open source and suitable for 60 world languages. And we also trained the GPT-3-like versions from scratch, for example, the Russian GPT-3 model. And we have done a lot of generative models, to be honest. So right, so we will start from some kind of overview. Why is ChatGPT important? Why is GPT-4 important? What's so special about it? And then we will dive into the general trends in large language modeling today, and we'll talk spend some time more discussing the licensing, because this is important, and this is also the thing that changed this year. Right, so we'll also speculate a little bit about language and thinking, and also stop on the new challenges and perspectives, right? So how did we even get from mask language modeling to ChatGPT, right? So we started with predicting the mask token or the next token, and then we are here in the instruction-based reinforcement learning with human feedback kind of setup, right? So of course you have been, seeing this picture a lot. I'm sure you did. So we will start discussing it, and then, it will help us understand what's actually going on, right? So we have basically 3 stages. Do I have yeah. Do you see my clicker? No. Not really. All right. So we have 3 stages right here. So we have the supervised fine-tuning, we have the rewired model, and we have the PPO model, which is offline reinforcement learning. So what happened there is we started with a general decoder model, let's say the GPT-3 model that we had, or any other generic decoder model that we could have in open source, right? So the thing is that for a year or two, from the first release of GPT-3, there was a strong focus on few shot learning and zero shot learning, right? So there was a strong focus on inline context learning, if you will, right? So how should we even compose a prompt so that the model would understand us and give us, the output that we actually wanted, right? So to do that, the instruct GPT approach was used. And that means that actually what we did, we collected the dialect setup, the dialect specific data, and the instruction-based data. So we switched from generic, generate everything, generate every genre of text, to dialect setup. And we also switched to instruction-based setup, because this is all of what zero shot is about. So let's train the model to perform a wide range of tasks in 0 shot and show it, we will be not just composing a prompt for a model to understand us better, but we will like basically chat with the model. So what we did there was we collected the chatting data, we collected the instruction-based generations, and we, evaluated the generations. We collected all the good data, right? So the good examples of how a language model should behave when you pass a prompt. And when we got, the supervised model, the supervised fine-tune or the policy model, right? So after that, we go straight to the second stage. And by the second stage, what we got is we still got a very good decoder model, which works in a dialect setup and in instruction-based setup. And by that point, it's already capable of generalizing over various ranges of tasks, right? But it also like can generate you everything. So it's not like basically safe, right? By that stage, it can already give you a good example on, how to solve mathematical equations, how to write an essay, but also how to rob a bank, right? So the problem we have here, we should pass some kind of human values or how to behave and how not to behave. And to do that, we will try to learn, a metric that would emulate human judgment on the quality of generations. This is an important thing, right? Because when like basically fine-tuning a decoder, what we look to up to is, the loss, the perplexity of the model, maybe some model performance on the benchmarks, but we're not aligned with the human perception of the quality generation, right? What's important and what's not. So basically after that, we once again collect good prompts. By that time, we collect the good instructions, and we generate few variants for each instruction. For example, here we have 4, but we could go up with more. Once again, we have a few results of generation for each instruction-based prompt. And when we pass it to human annotators who should evaluate and annotate them in terms of, is it corresponding to the instruction? Is it task specific? Is it safe? Does it contain like harmful content or something like this, right? So we pass our human judgment and we also range the results. So we not just mark this one is good and this one is bad. No, what we do is we arrange them in terms of that one is best, this is like slightly worse, and this one is even worse, and so forth, right? So after that, we have a reward model, which basically what it does, it provides us with some proxy of human evaluation, and that's why the quality is perceived so good, right? So it's all aligned around human judgment on what's good generation. And for example, in some tasks, when you chat with ChatGPT or you ask it with around some, informative questions, for example, it could give you a simple answer like, what year was like London established and stuff like that. And it won't give you a simple answer because it's all centered around this reward model. And for example, a better judgment is correlated with the longer answer, right? So the longer is the answer, there's more probability so that it would receive good evaluation. And that's why it's so worthy, for example. Right. And after that, when we got this proxy of human evaluation, we just pass it, we get the reward model, and we fine tune the supervised model that we already had. And we pass this reward evaluation into the loss and update the model. So that's what we do. So I like this picture much more. To be honest, this is kind of the same thing. So we have the unsupervised pre-trained model. We have the supervised fine-tune, which is slightly better. It understands like human language. And we have the last one. This is this smiley face, which is like basically with some kind of human values that we passed, right? So that's what we get. So at that stage, like basically a model is capable of generalizing over various people experience and various data, various kinds of knowledge, various personalities. It can impersonate like different characters. By that stage, it basically can chat and understand what are the instructions that you give it. And by that stage, it like learns not to give you the output around like how to rob a bank. And that's what we have right now. But what's actually the progress that we've made. And I would like want to stop a little bit here and discuss how it's correlated with the general perception of language, and the theory of language that we have, right? So I would say like the big points in our timeline is the classic language modeling, probabilistic, where we just generate common phrases with hidden Markov models and conditional random fields. For example, when I started doing NLP, that was the thing. So I'm old. Right. So after that, we switched. We had the first neural revolution in NLP, and we got good word embeddings with word2vec, fast text and stuff. And we could explore distributional semantics in context, and that was a good thing. After that, we passed word embeddings into LSTMs and other recurrent neural networks, and we got better generation with meaning. So we basically, at that point, we could generate something like some phrases without syntactic errors. And by that stage, we could generate some phrases without syntactic errors and also frequently without semantic errors. So this is important. And also we had some problems here, right? So we had the catastrophic forgetting, for example, and we don't have that with autoregressive language models right now because we got all the context at once. And we can even generate meaningful text because of that, right? So the text, which correlates with the length of the context window of the model, gives us an output of a meaningful text without syntactic errors and both without semantic errors frequently. And because of that, we also have like better dialects. And now when we have the reinforcement learning with human feedback set up, we also have the last part, the intents. Right? So why was this phrase or that text even produced? Because this is what instructions are all about. And I would give you like a very, very generic figure of the layers of language. It's really very generic, so any theoretical linguist would challenge me on showing you that. But well, we have the phonetics and phonology on how we produce the words. We have the morphology and syntax, which is basically the grammar, right? Then we have semantics, which is lexical semantics, the meaning of words. And we have the discourse, like the meaning of words in context and the meaning of larger text and the text structure. And after that, the last layer is actually, after the discourse, is pragmatics, right? So you don't see that here because we have this zoom menu, but here is pragmatics. Pragmatics is basically, why did we even say that? What was the intent? This is the pragmatics layer, and it's like the last layer we could get. And well, actually, our progress is mapping really well on that kind of perception of language. So we achieved finally the last layer that we didn't touch previously, right? And the pragmatics, how to understand like pragmatics, it's actually, I like this example mostly, right? So we have Brian who wants a job. So he writes a cover letter for his resume and he produces, with instruction-based setup, he produces a generic letter on with my other eagerness. I would present my CV. I want to work at your wonderful company and stuff like that. And the man who receives that, basically what he reads is also the intent. So Brian wants a job, right? So this is the pragmatics part. And this is what we actually learn with models because we have the instruction-based setup. So the instructions are basically the expressed pragmatics in some way. Right. So when we get here, we also can reverse, the task and try to solve the opposite task as well. So there are already works on that. So we basically can learn what instructions corresponds to each text, right? So for each text on the internet, for example, for each web corpus or, article on Wikipedia, we can generate a few instructions that would be absolutely meaningful for that kind of text. And that would be like a good hypothesis on why this text was written. And we can actually, annotate the data like this and get all of the intents all over internet and finally understand what's going on, right? I think that's kind of nice. But now I would like to switch a little bit and, discuss the general context, because we were focusing on the ChatGPT stuff too much, right? So what's going on besides that? Is there anything open source? Can we get an open source thing like this? Yes, we can, but we don't have yet, so we're trying. So that was part of the Hugging Face review on the instruction-based and dialect-based generation. I think it was dated around March, so a lot of things changed there. So we got the Blender bot here, we have the Lambda model, we also have the Anthropic's Claude, we have the ChatGPT, and we have the DeepMind's model also. So we see that we don't have much of the reinforcement learning with human feedback here, but we have in the proprietary models that are not yet open sourced or not yet released, right? So we have the OpenAI, Anthropic, and DeepMind. So can we get something like this in open source? Right? Well, we can get at least the first stage, right? So we can have the supervised fine-tune, and then we can decide whether we even want the reinforcement learning with human feedback part, the second stage. Well, right now we don't have it exactly in like complete open source, because I would heavily advocate for licensing everything under MIT license or under a patch license. We don't have that yet, and a lot of things changed in licensing large language models like the last year and especially this year also. So for example, the last large language models released by various teams. For example, I love Galactica model, which was trained on papers with code data set. It's released under the GPL license, which is like better than proprietary license for sure. However, this is the license which is not very popular among industrial community, because you cannot use it for commercial use. So because you will have to open source everything that you do with Galactica model, you will change it, you will retrain it, you have to open source that and disclose that you have been using Galactica. Like people in the industry or like product related startups, they didn't like that eventually. So this is limiting the number of implications, the implementations of the models that you can get. Right. So we also have the Llama model, which is very influential for sure. And it is released under Creative Commons license, which is also a rare thing, to be honest. Like for any other year, it would be a rare thing, but not for like 2023. So we have the special license with additional points, but it's also Creative Commons, and it's not suitable for commercial use. It's not suitable. It's suitable for research purposes only, to be honest. And on the other side of spectrum, there is like the completely open source language model like Bloom, which is like community based, and it supports a lot of languages, and it has a lot of like checkpoints of different size. However, it's also not completely like very permissive, because it's released under the OpenRail license for models. And this is a new thing that was introduced. I would also say that that's not exactly an open license. So these are, for example, the licenses that were used to release large language models frequently. So the Bloom model and also Stable Diffusion and other models were released under the Rail license. What's even the Rail license, right? So the Rail license is responsible AI license, which is community-based, and it tries to, find some balance around being absolutely like giving you the checkpoints and giving you permissions to use it both for research purposes and for commercial use. However, it implies strict limitations on the number of industries and implementations where you can use the model. So in that terms, and any lawyer would argue that it's not a permissive license. And there are a lot of things that are prohibited here. Like I've stated them here, but that's too much to discuss. There are some generic things like you should not use this model for not safe for work implementations, for example, but also there are some things like medical advice. And this is a questionable thing, right? Because a lot of people in the world, like they don't have access to some medical advice. And maybe that would be a good thing for them to even have some amounts of like second opinion of automatic doctors, but under OpenRail license, this is not possible. So we have this. And also what we also have the MIT and Apache 2, which I generally like, and I advocate for releasing like large language models under that licenses, of course. And well, a lot of models were released under these licenses previously, but not now. So what we have, for example, right now, that's generally a good moment to present an open source language model, right? Because we have a new approach to fine-tune language models and to receive, good feedback from the community. Everyone wants to build like in-house ChatGPT and stuff like that. Yeah, and we know that it's like less risk, to be honest, right? When we explore new architectures, that's high risk, high reward, but then we have low risk, high reward. So everyone is diving into the supervised fine-tune, instruction-based supervised fine-tune and stuff like that. So we have received as a community a lot of fine-tunes and a lot of new GPT-3-like language models that could be used as base models to later be fine-tuned in terms of supervised fine-tune, instruction-based, and the PPO model, right? So what we have, for example, is we have the Llama model, which is under special license, not suitable for commercial use. We have its fine-tunes, which are released under like special licenses. They are basically instruction-based fine-tunes, the Vicuna, the Alpaca, and the base models. However, well, this is a tricky question. And, when I was scrolling through Hugging Face and, finding the licenses that were like in the paper and on the checkpoints on Hugging Face, sometimes there are different licenses for each model. For example, for Alpaca, you can find that the code for pre-training is Apache 2. However, the weights of the adapter is under Creative Commons license. And you cannot use just simple Alpaca because this is the adapter over the Llama model. So you have to have access to Llama model to use Alpaca and stuff like that, right? So you can find for sure the re-uploaded checkpoints of Llama on Hugging Face, and they're even Apache 2.0, but that's somehow it's here on Hugging Face, but that's not the right thing to do. Just for you to know, right? So we have the Galactica under the GPL license, and we have the Blue model under Rail license. And well, hopefully we have some base models and some instruction-based fine-tunes under Apache and MIT licenses, right? So we have the Cerebras GPT, which is the base model, like GPT-3-like. We have the Stable LM also, and GPT Neo X and Pythia. They're both like very basic decoder style language models that you can fine tune on the instructions, or you can tune it anywhere like for any other task. And we have also already the instruction based fine tunes like Open Assistant, like the chat base on the GPT Neo, and like Dolly, it's pre-trained on Pythia, as I remember. Right, so I also like really this comparison by Cerebras GPT team, which also discusses the levels of openness of large language models, because this is not also a licensing thing, as we discussed earlier today, and I absolutely reciprocate with that. We could do a lot of research comparing the models and how they pre-train optimally or not optimally on various data sets, right? So to compare models in a fair way, we should also know the exact data sets that were used, and we don't have that knowledge for many language models. So what we have here, actually, we have the Meta OPT, we have the Chinchilla, the GPT-4, and we can compare them not just in the terms of license, but also like the checkpoints, the data, the architecture, and stuff like that. So a good, basic place to start is to use like Pythia and Cerebras GPT. And, there are like differences that Cerebras GPT is Chinchilla optimal. So they use this this knowledge around, what's if you have the fixed compute, how many parameters should you get and how much data should you use, right? Well, in terms of the performance on the downstream tasks, however, that does not help at all. And the style that's, accepted right now, however, I would not accept that very much personally, is that you release a model, you release some kind of, Hugging Face card, you release the checkpoints, the data card, and not every release is followed by a paper right now, and not every paper includes a good comparison and a good evaluation on the downstream tasks. So some of the numbers that we get is, of course, the human evaluation around the quality of what we have. And for example, Vicuna tends to achieve, comparable performance in terms of human evaluation, but that's not exactly relatable to the quality that we would get if we only are interested, for example, in question answering and open domain question answering, or in chatbots, or in summarizing stuff and stuff like that. So you should definitely reevaluate that. And well, we need much more, comparisons like this, to be honest, to just explore what are the possibilities, what are the limitations of the models being released right now, because we don't have that yet, however. Right, and the same thing goes with data sets. So we have a lot of instruction-based and human annotation data sets, which are really good, that are somehow open source. Some of them are under Creative Commons, once again, some of them are under Apache 2. And I didn't include all of them. There are good sources, for example, awesome instruction data sets on GitHub. You can find this lists. So basically, the hardest people working right now, apart from NLP researchers, would be corporate lawyers figuring out what we actually can use for commercial prototypes, because this is a big thing. And we have everything released under different licenses. Some of them are permissive, some of them are not. And some of them are not yet a common practice, like Creative Commons. How do we even treat a code written under Creative Commons? That's a question for sure. Right, so backing up a little bit and returning to that point. So we have reached somehow the final layer of language, which is the pragmatics, which is very suitable for instruction generation. So we don't have much layers yet in linguistics. We can find some various points of view on how the layers are received. However, we don't have much happening in linguistics after pragmatics, because after that, it's cognitive science. So this is the border, right? So what do we know about the nature of language and what we have right now, and where would be the research questions be focused in the recent years? This is a very speculative part. I get this. So we have language generation, automatic, and language production, which is a common term for how do we produce language, right? So we have the statistic generations that we have here with intents and values. So we have still here, and what is needed, for modeling language and language production, and what we don't have is this part. So when I work with cognitive scientists, where the people do fMRI studies or other studies, including language instructions or language data. And what they wanted to know is what's happening here. So we know we have semantics, syntax, phonology, and all the other layers, right? So we have the articulation. We are not very interested in that. And we are not interested very much in phonetic encoder and encodings as, NLP people. So we somehow can, emulate lexical selection because we have probabilistic models here, but we don't know how is conceptual preparation done. And this is a big question because there is no good understanding what's happening here, right? So we know the language is the mechanisms that tends to have, a lot of stuff happening in various places in the brain, not just in the cortex, but also in various parts. So we don't know what's happening here, but we need it to model what's happening, right? Where are the intentions coming from? And how do we even, choose what to say? So that one part is, I think, the most challenging for the next years. We, of course, have other problems to solve in terms of being more like engineering oriented. We have the scalability problems that were discussed earlier. Once again, we have a lot of regulation and ethics problems to, how do we even achieve them, and what are the ideal, results of a model being safe. We have the non-compositionality problem on how the meaning of the sentence and the meaning of text is composed from the meaning of individual words. We have a lot of problems concerning the multilingualism and world languages being represented in the language modeling practice, because languages vary greatly, and there are like things that you would consider as the English speaker, you would consider exactly like exotic, and statistically they won't be even exotic, and you would be exotic, right? And right now it's not at all like represented in the language modeling because it's like heavily English oriented. Things tend to change, like, and now it's the decade of indigenous languages in NLP. Hopefully that would change. Right. And we also have, of course, the grounding problem. So besides of talking to cognitive scientists, we should also, start making friends with robotics people, I would say. And, they already start to use like language modeling and instruction-based generation to, give instructions to robots. So this is a good place to start. And they also have, the corresponding visual data. So that would help us maybe, doing the conceptual preparation modeling stuff and stuff like that. And talking about the conceptual preparation, a very close look to it is also, how do we even approach language and thinking? Because what we want to see from what we expect from language models is not just language, right? So when we evaluate models on benchmarks like Glue, Superglue, and Big Bench, they're composed not just of some ordinary phrases, if you will. They are composed of like intellectual tasks. So what is expected of language models is to emulate intellect, like human level intellect and like superhuman intellect, and to just evaluate it through language. So language for like in terms of engineering, you should have like some interface to evaluate intelligence. And this is what language is for, right? So is thinking even possible in terms of cognition without language? Yes, it is. And there are studies that show that we think sometimes without language. Some people can think, in terms of visual cortex, they can imagine like sounds, they can imagine images and stuff like that. So thinking without language is possible. And we wanted to model thinking in the end, right? So language and thought, they influence each other heavily. And this is a big part of the research, like through the 20th century. And there are a lot of works on that. And there are also like various hypotheses, for example, like cultural neuroscience, which states, for example, that at some point we had the coevolution of the brain and cultures. And some studies that are like, there are not very much studies on that, but if you compare, for example, an English speaker in the fMRI, and you can compare like a Japanese speaker in fMRI, and you will give them, for example, the benchmark tasks, various intellectual tasks through language, you will see differences. You will see differences on how the language tasks and intellectual tasks are solved for English speakers and for Japanese speakers, right? And that particular example, for example, is Japanese people use the same zone in the brain that's used for syntax, which is used like for like syntactic production, and this is also what Europeans do. However, the Japanese children in school are taught to make, to count with visual examples, and they can count simultaneously when they also product speech. So if you are in the, business meeting with a Japanese person and you discuss money, Japanese people can basically, count stuff in their head and also talk to you, and you cannot do that, right? Well, there are like exotic examples like that. They're not very much explored, but this is a thing. And a lot of also varies, of course, in terms of individual mechanisms that we have. So what's the difference, and how is it mutually influenced, right? The thinking and language, and that would be a problem for us very, very soon, right? So right now we have the intent-based text generation because we can model the the layers and the sequence of intents right now, so we can basically predict what would be, for example, the next intent. So would it actually lead us to some kind of self-supervised cognitive functioning? We don't know, but I would say this is a real boundary in language modeling right now for the next years. Yeah, and this is where I should stop. Thank you. Thank you very much.
Thank you, Tatiana. It was a really nice talk. Do we have questions from the audience, maybe? I have one to start. Yeah. Sure.
Thank you for the presentation. Returning to the three-headed monster picture.
Yeah.
I wanted to ask you if you could provide insight on what is the cost value distribution for each head, like how much time resources is spent on each step and the value that it adds to the model.
Well, that's a good question. Thank you. Thank you very much. So in terms of these stages, we don't know much on how it's working right now because it's a proprietary thing. We didn't know much for ChatGPT. We know even less for GPT-4, right? We can speculate and we can have some guesses. For example, if this is the bigger model, like DaVinci one, and there were some speculations on Twitter, not a very reliable source. However, that's a fine-tuned DaVinci model, right? So this is very computationally expensive, but do we have to have a reward model also this large? We don't know. And as much as we have experienced it, we wouldn't train a reward model also this big. However, that could be a bottleneck if you make it less potent, less generalizable. In terms of human evaluation, which is happening right there, there are actually a lot of points to be evaluated. So here comes, is the answer grounded factually? Is the answer exactly correct? Do I like this answer? Is it ethical? Does it provide moral judgments? And a lot of stuff which is all around AI alignment and stuff like that. And for example, for factual groundedness, if you use a smaller model, it will also, it will basically learn some amount of information, but not everything, right? So you need it to be quite potent to evaluate the outcomes, right? So I would say it's also expensive. It's not cheap. Yeah.
Thank you.
Well, a good thing that we can use open source models like PFS, Rebus GPT and stuff like that. They are all under 20 billion parameters, and we can start, from there at least.
Thank you. Yeah.
Yeah, thanks for this in-depth overview. I'm curious, you talked quite a lot about, licenses and all the stuff.
Yeah.
But as far as I know, the probably a bigger issue is a legal aspect of, using these recommendations from LLM models in different areas, such as medicine and other stuff. Could you say a few words about your vision of, the nearest future of this area?
Yeah, thank you. So this is actually why we have the rail license and stuff like that, right? So we have a license which is tends to be permissive, but it has this wide range of limitations on it, based on the implementations of the model, right? So a common thing to not to do with language models is medical advice, financial advice, moral judgment and ethics and stuff like that, and also personal information, right? So these are the very four that are mostly not used in every area, and there's some consensus on that. However, well, still there could be cases that are involuntary for us. For example, there was a case when a man was chatting with ChatGPT, like maybe like last month, and he committed suicide because the model like explained to him somehow, and he was convinced that it's the right thing to do. And that's a questionable who is responsible for that, and is there a way to even prevent this in terms of engineering? And we don't know that, but I think the consensus that we should get is it does not lie in the corporate area. It's like mostly a larger thing to do. And what's happening right now is the governmental regulations, right? The governmental regulations that happened in Canada, in Italy, and all in other countries. And in Europe, there is the GDPR, you know, which prevents the models from using personal information of the users. And it's also a heavy implication on ChatGPT. So I personally think that there would be some, you know, some kind of international consensus on what's good, what's bad, right? We don't have that right now. We have like a lot of international documents in terms of UNESCO. We have the Carnegie Mellon recommendations. We have like various institutions that publish, you know, their approach to AI alignment. However, it's not at all like based on engineering. So me as an engineer, I'm reading all these documents and I get, you know, the ontology of the sensitive topics and the prohibited topics and all of that. But how do I then implement that and how do I evaluate it? And I don't have resources or tools for that. And we should come together with some of the tools and some consensus, but we don't have even a consensus yet. Yeah.
Additional questions?
I also wanted to ask about like language models are not that great at math. Do you think that is something that can be solved through language modeling or some new kind of methods are required?
Yeah, so there are some general limitations on large language models. For example, like all the things around time and, you know, predicting what would be next. So the language models don't have like capability to predict, you know, time series and stuff like that. However, the architectures that we use right now, the decoder-based architectures, are widely applicable to the data in other modalities, right? So there are already some open source architectures like Cosmos or other stuff where we can introduce in the whole sequence of tokens, we introduce the tokenized in some kind of way, like the image or sounds and stuff like that. So we can basically make language models multimodal without stopping being language models, right? So language would be like an internal tool to, you know, build multimodal intelligence and describe what's happening in the images, in the sound, and you know, generates the answer in language. Because being able to, you know, describe the results in terms of language is, you know, a very, very useful interface to have to communicate with artificial intelligence, right? There are other limitations apart from time series that I mentioned. For example, the grounding problem, and I think that would be solved, you know, through some kind of AI agents that are developed right now. There is a challenge on new RIPs and the last year also. So this is the approach that has been already grounded on some kind of work. So I think that language models will receive their grounding very soon. Well, at least in some kind of you know, playground environment. This is possible. However, of course, we don't have, you know, the exact, for example, also personalization. If we talk to a language model and we prompt engineer it to behave as a person of different profession, for example, or an exact person like a scientist from the past, we can't control the amounts of data which it's used. For example, I would use like a prompt, for example, like behave as Copernic and discuss, physics with me. And you should be able to discuss it with all the knowledge that was obtainable for Copernic. And it will eventually, it will also use the knowledge from other sources as well, from the news sources. So we have this data leakage knowledge control. So maybe the external like vector databases and stuff like that could be implemented additionally, or graph-based databases and stuff like that. Structural information that could be passed and controlled to language models is also a limitation right now. Yeah.
Okay, we have maybe time for one short question.
I believe we have a lot of time.
A lot of, yeah.
Yeah.
That's nice. So then I have a question of myself, if you don't mind, because I have a position and I can do it. You've been saying that we're on the edge of the using of the cognition science for the language models, but in the same time, you're showing the picture where these language models are presented as a lion monster. So how do you think, is it even possible to apply the cognition science methods to the such a lion thing as a language model?
Yeah, thank you. Thank you so much for that question. Well, I personally believe, of course, that's just a, funny thing to have in the presentation, like language models, monsters, stuff like that. Yeah. However, I think that the methodology influence goes the other way around. So basically, we should implement some methods from cognitive science to large language models and not the other way around, right? So what we do have is we have some practices, we have some cognitive studies. We have a lot of theoretical schemes on how various intellectual abilities could be organized, right? So they're mostly theoretical, and how is memory organized? Like how are executive functions organized and where? And there are some tests designed in terms of, trying to find limitations on executive functions. How's your human attention working, and how to distract you? There are a lot of famous tests. For example, the gorilla test. Have you seen it on YouTube? When there is a short video of people playing basketball, and you are given a task to count how many times they passed the ball, and you try to count how many times they did the pass. And on the background, there is a man in the costume of gorilla going on, and you're absolutely missing it when you're counting the passes of the ball, right? Because your attention goes the other way around. And there are other tests like that, but they're tending to locate executive functions and try to make falsifiable hierarchy of how that's working all together for various people, make some kind of generalization. We're not very successful in that, for sure. And we're even not very successful in terms of finding limitations and cultural differences, language related differences. So there is a lot of things that are blocking us from getting the exact methodology and passing it into language modeling right now. However, I think there is a great demand for that. I was personally reached a lot of times this year to talk about, what's happening in the stage of conceptual preparation, what's going on there. And there is a great demand because right now we can be at the stage when we are not modeling the sequence of words, but we're modeling the sequence of intentions, right? Because we know the exact intentions corresponding to each task and to each phrase, to each text, right? So what's the normal, what are the normal patterns, the generalizable patterns in terms of the sequence of intentions? And we needed actually to make, to include more information like that in language modeling, right? And we don't have that. So I basically think that we could include at least a lot of tasks that are cognitive studies related into benchmarking. And this is a very obvious thing to do because benchmarks are already intellectually related, and they are, not very much cognitively motivated. So, for example, like at Big Bench, which is, the most beautiful evaluation tool and the most reliable tool that we have right now, because it has more than 200 intellectual tasks included that are in various languages, and they tend to, try to test different intellectual abilities that are really varying, not just natural language inference, not just the ability to understand the meaning in context or, machine reading and stuff like that, but really various sets of tasks, right? And they're all very much oriented around like the data sets that we already have. Let's look at what we already had at Hugging Face data sets. Let's look at we already had like on papers with code. Let's combine it all together and make an evaluation tool out of it. But there is not much to to analyze in terms of the cognitive abilities, in terms of memory, in terms of attention, in terms of other executive functions, in terms of how is the knowledge used. And there are a lot of, various things to check also. For example, in generative grammar, which is one of the popular theories around how the language is produced and what are the general rules of language of the languages of the world, right? We have the difference between the capability of the model and its performance, right? So you can have, as an English speaker, you can have a lot of information in your memory, you can study, physics, law, but somehow like early in the morning before your first coffee, you are asked around something like this that you have already learned and you cannot answer, right? So this is the difference between the capability and the actual possibilities that you have. And we are not discussing these differences in terms of evaluating language models right now. I think we should, because language models are like in terms of like sampling and other popular strategies of generation, the quality that we get is not stable, right? So you can ask a model, for example, what year was Pushkin born and stuff like that. And it will give you like maybe 8 times out of 10, it will give you some sequence which has the correct data in it, and sometimes it will not. So I think that also should be taken into consideration around, all the possibilities of the model to extract the exact information that it has from the training data. Yeah.
Okay, thank you. But my question was a bit on the other angle. I'm saying that is it correct to apply these cognitive tests which have been developed for a human, which is has somewhat grounded cognition on the embodied intelligence and that stuff, on the language model which has been seen at the best, I don't know, some pictures and some words. That's it. Is it correct?
Well, I think I think that's correct in terms of the goals, because we just want human-oriented intelligence. We don't have like completely non-human intelligence. We want it first to be human and then to be superhuman, like AGI. So if you look at the definition of the AGI, right? It should be human oriented. And that's why, how do we evaluate humans? The same way we evaluate all the other systems, not just language models, but anything else. For example, there was the ARC challenge, like in the later years, where the systems should provide their reasoning skills on the visual data, right? So we also—
But it's not, has been not working as it showed.
Yeah. So this is one particular example where it didn't work out, but that's possible, right? Because there is reasoning apart from language, and we know that. And we passed the same evaluation techniques both on humans and on systems, right? Because we just want the intelligence to be like human-like and then superhuman-like, right? But in terms of grounding, of course, we have like different capabilities. And there is no consensus either on is it like is it the correct thing to run a Turing test, right? For example, like the big bench is heavily reliant on the Turing test because it introduces, a large amount of data sets into this dialogue setup where you chat with the model and you evaluate what's the amount of success that you get, the correct answers that you get, right? So is it the correct thing to run a Turing test? And there is a lot of literature on that and a lot of, various, I would say like variants of Turing tests, which tend to be like much more harder and are not related to text modality at all. For example, like total Turing test, and there is such thing as truly total Turing test that has to achieve neuromolecular analogy between some kind of artificial system and the working prototype that we have, the neural system of a human. Well, I don't think that's achievable. Yeah, but this is as much as a scientist can get methodologically. And I actually think that we are not ready for some kind of tests like that. Yeah, there is definitely a big gap methodologically on how we should approach evaluating systems after Turing test, and we don't have that yet.
I see. Thank you. I think that's enough of my questions. Sorry, there is a question online. Please, Vladimir, go.
Hi. Thank you for the wonderful talk and a lot of answers. I have a related question to the math and to the previous question, actually. We don't know much about GPT-4. I hope you can hear me, right?
Yes.
Yeah, we do.
Yeah, good. I think we don't know much about GPT-4. The fact that was recently announced or discussed that GPT-4 was tested on interviews with programmers like Amazon, Google. They have these shared platforms for testing programmers online, and GPT-4 solved like best out of better than 100% of all other participants historically on that platforms. At the same time, GPT-4 showed very poor performance on math problems. So maybe you can share some insights, some ideas, your opinion about this discrepancy between this, it's like good performance on programming tasks and quite moderate performance on simple mathematical tasks.
Yeah, thank you. Thank you so much. So we were talking later about the limitations, right? So being able to solve math and algorithmic questions is also a limitation that decoder-based architectures face right now. As I remember, there is an update on GPT-4 that introduces exactly addresses exactly this question. So GPT-4 right now should have an evaluated, better performance on the math tasks. And, I have been working on, exploring its capabilities right now, and it did make a lot of mistakes in math, like in like school level math. So but at least what we know about GPT-4, and this is the only information we can get from the paper, is the evaluation results. And I think that's a very related result that we can, see in the paper of GPT-4, the technical report, is its performance on professional exams and tests, right? So there is an exam in law, in physics, in the school state exams like GRE and stuff like that. And there is also one of the exams was the Code Forces Academy, and the Code Forces Academy is the new set that was introduced like after the model was pre-trained, right? So the data could not exactly leak into training and was only used for testing for sure. And the quality on the Code Forces, which is actually like very similar to lead code and stuff like that, is near zero. And this is like what's stated in the paper. So they have near zero performance on the Code Forces. Yeah, so I think like solving completely new, not introduced before algorithmic tasks in maths, maybe it's not just a very right thing to do, because we have a language model and eventually it does tokenization of the sequence, right? And this tokenization, we don't know how it's done for math. But in general, if we run a decoder model that was trained on a corpus of texts, it tokenizes a sequence of math equations the same way it does approach the sequence of texts, right? So, you know, are math operations a separate token or not? And you know, the long numbers, like the big numbers, are they tokenized like a lot of tokens? And is it the right thing to tokenize large numbers? I don't know. I don't think so. So right now it's solved with an external plugin, which is the Wolfram Alpha. It was introduced that it would be used in, you know, solving math equations in the GPT-4 interface. So you will have actually the routing, and the other model will do it for you, not GPT-4. And yeah, this remains a limitation. I basically think that that's not the right thing to do to approach it through decoding architecture.